Welcome everyone to our next webinar. Thanks everybody for coming. Looking forward to this one for quite some time. A topic that is everybody is hearing about, everybody's working with and listening to and understanding as best we can, and we wanted to talk about it in this world of Race Studio data analysis, and that is artificial intelligence. And probably 3 or 4 months ago, 2 or 3 months ago, James Colborn, who's going to be our guest today, is he contacted me and we talked about it a little bit, and he said, "Boy, this is a topic that I'm learning a little bit about, and if I have a little bit more time, we can see how this is going. So we'll see how this works out." But James brought this up to me, and it's something I've always wanted to talk about. Thank you, James, for coming and joining us today.
Thank you for having me. It's lovely to be here again.
Absolutely. As James has been here for a good number of these, this is his 13th time co-hosting with us, and talking about different things. I just heard from just chatting with James earlier. He was over here and raced locally near me. He should have called me. I could have came down there, and we could have played around a little bit, but no. The glad that you traveled around a little bit and you came back over here for a little bit in Portland. And thanks for joining us, James. Tell us a little bit about what you've been doing lately.
Yeah, absolutely. I so as you said, it says here avid Formula Ford racer. That hasn't changed. I still have my Formula Ford. I still enjoy that an awful lot. But it was nice to get back into, as they've often referred to, as tin top, which I did at Portland a couple of weeks ago, or about 3, 4 weeks ago now, at a lucky dog race. And so we did a Saturday and a Sunday in blazing hot sunshine in Portland. It was absolutely lovely, and it reminded me of how beautiful the Pacific Northwest is. And so, yeah, just having a great time, just enjoying racing, but at the same time, I'm still working a lot with the AIM Technologies AIM shop for their AIM Academy, and have been thinking a lot about AI. And I think that it's creeping into every part of our lives now. And I felt like data analysis was just one of those areas that this may or may not find applications that help us do something different, something better. And so I wanted to have a look at it with everyone today.
I appreciate that, and when you brought it up, I like most everybody, and I see a couple of people in the chat talking about that they've been starting to dip their toes into this a little bit, as I have as well. Not yet deeply into this piece of it, although I have huge enthusiasm and wishing to have more knowledge about this particular piece. So I am anxious to hear what you have to say today. But just like everybody, you started to dabble in it, to ask questions and do some things on my own on different things. And it's while it, knowing ahead, looking ahead at some of the slides that you've put on there, AI is such a wonderful tool, great, fantastic, powerful, but it can be wrong. And I've noticed that in a couple of your slides. One of the very first times I did this, I was trying to do a financial calculation, and I didn't understand some percentage math that I really wanted to do, and I didn't want to dig it up and look up the process. So I just went onto there and said, "Hey, if I'm do this," and it came back with an answer like in 2 seconds, and then I used that to backwards engineer myself into building whatever I was building. I couldn't get it to match, and at the end, it was a simple math problem that it got wrong. And
Yeah.
once I got in there, I finally was convinced. I convinced myself that I was right, and I wrote back and I said, "You gave the wrong answer. This was it." "Oh yeah, you're right." It's like, well, wait a minute. So be careful. If for all of us that are using this, make sure there's backup ways of understanding. And I know that's going to be on some of your lessons learned here as we finish up. But everybody needs to keep that in mind as well. It can be wrong, and it can be convincingly, very convincingly think it's right and it's wrong. So be very careful. So okay. Okay, well, James, I appreciate again you being here, and we're looking forward to this. I'm going to kind of just lay it over to you. I'll run the
Okay.
presentation here. We're going to do a little bit of live data as well with James partway through this. Make sure, again, for those of you that are watching here live, if you have any questions, put them into the question answer box. There'll be some links that we're going to have that we'll go into the chat box those of you watching this later on YouTube, we will all of those will be in the description below. If we mention them here, well, we'll make sure that they're included into the description so you can find those in the YouTube description. So I appreciate it. And with that, James, let me go to your first slide and let me turn it over to you and give us an idea about what we're talking about here today.
Thank you so much. Just to answer a question that somebody just asked, do I ship my car over to the US? No, I drove a car that was already in the US, which was in the chat box. It's interesting. I get very interested in what's being asked on the questions and then stop
Absolutely.
thinking about the presentation. So let's think about this in terms of AI. Now, I have been the last 6 months, I would say. Before then, it was you see people using ChatGPT to, potentially make caricatures of themselves or potentially make images or all sorts of stuff. And it was one of those things that, as somebody who's, Gen X and near as makes no difference, 50 years old, the question was, would I find applications for this? And so I forced myself into learning and looking at this in a different way and started taking a lot of online training courses, of which there are an absolute ton. Fascinating of which, if you find one from 2024, you're like, oh, that feels a bit out of date. Maybe I should find a newer one because it's moving that quickly. One of the things that I started to think about was the fact that, I'd been using Gen IO tools like a Chat GPT, for example, like a search engine. And one of the things that I wanted to be able to think about was how do I start getting better at what I'm asking the tool to be able to do, and then just go through a series of trial and error. And one of the areas that really sort of popped up was starting to look at race-related data. And so that's the nature of what we're going to talk about today, just a very early sort of teaser into some of the stuff we've been looking at. And so let's talk a little bit, first and foremost, core principles of AI. These are things that I've learned. And just like I'm old enough to be able to say, just like when the internet came out and everyone thought the internet was going to be a brand new revenue stream and the best thing in the world, the reality was is it took existing businesses and it moved them into a more convenient and an online type of environment, which we saw with things like commerce, we saw with things like God knows what nowadays. Well, the reality of AI tools is they are tools. They should make any kind of analysis you do faster, easier, or more in depth. And I put here better. It's a very blunt way of saying it should make things better. But in many instances, when you're dealing with large sets of data, I think that having a system be able to think through different types of analysis that you may just be thinking of, and this is where it gets sort of so interesting for me, which is when you start looking at something, I must say I'm not bad at Excel, but I don't know how many times any of you have gone in and said, okay, now I'm going to Google what a formula needs to look like for Excel so I can get the outcome that I'm looking for. Whereas in an AI environment, I would just ask the question. It's on the top of my mind. I'm thinking about this. Can I ask the question? And so I think it's important to be able to think about how we're going to use it. I'm going to talk a bit like that. AI is therefore a tool. It won't produce magical insights unless you actually use it. And so we're going to get into the core principles of what I've learned so far in terms of being able to apply that. The quality of what you put in will determine the quality of what you put out. Or your output. It's the same in every type of scenario that we've probably thought about, and we've heard this in many formulas in many instances. Rubbish in, rubbish out, or however you want to describe that. And the quality of how you use the tool will determine the quality of your output. So we're going to look at that today and be able to potentially change the way we approach conversations that we may be having to have dialogue. Now, AI can get things wrong, just like you said, Roger. I have mastered the art of shouting at AI with capitals, which is my angry voice when I'm talking to AI, being able to say that is clearly not right, because the fastest lap time you've identified here for this particular driver is nowhere near the fastest lap time they've done in the data that I provided. And so I think a lot of that is to do with the type of model you can apply, and we've seen scenarios. So I think that's going to be an important thing as we think through of all of the different forms of AI tools, you're going to start seeing different variations. And so I'm going to talk about that a little bit. It won't be complicated. It'll be mostly just make sure what to expect if you're using it. And then the last thing, as I said, sort of the core principles I've looked at is don't be frightened of experimentation. And so I've been spending a lot of time asking ridiculous questions, asking for different sorts of views, because, some of it could be rubbish in, rubbish out, but some of it could be particularly useful. And hopefully we get into something which is more applicable as we go through. Now, I wanted to start thinking about example use cases for race data analysis. Now, since we put the listing up online, I've had some few people contact me, people put stuff online, different applications that they're using. And so one of the things I will say is that this list is by no means exhaustive. In fact, I think this is just a very, very, very small percentage of the potential applications. And I've started to see other people put AI-based analysis online. Samir from Your Data Driven put up something very interesting the other day on LinkedIn talking about AI analysis and being able to start look at different sorts of trends. Now, I'm a driver more so than an engineer. I think most people know that when I look inside the car and go, "Yep, that's an engine," and that's about as far as it goes. But when it comes to driving, I'm more interested in what trends I can see as a driver. And if anyone's ever followed many of the YouTube channels that I've got, and YouTube channels, like I've got more than one, YouTube videos on my single YouTube channel, you'll be able to see that most of my focus is looking at drivers. So that's some of the things that we're going to have a look at today. Now, some of the things that race data analysis is useful for, when there's large amounts of data to be analyzed. Today, we're going to look at a scenario where we're using endurance-based data, and each driver's done 60 plus laps. And they've done 60 plus laps where there's 70 other cars on track, and there's all sorts of conditions to be able to work through, whether there happen to be full course yellows, local yellows, whether there were scenarios where something had happened on track which caused the driver to be able to do something. And we're not going to necessarily be able to know exactly that, but we can use sort of instructions to be able to help us start cleaning up some of this stuff. The next is when we start looking at multiple variables within that data. Now, I'm going to go super simple today, but when you think about multiple variables and a large set of data, what you're thinking about is that even in a driver analysis and an endurance race, there are certain things we need to know. There are different drivers. There are different sectors on the track. There are different conditions that might be existing on that track. You add that over 60 laps each, and now you start looking at different variables. How can I start looking through that? Which is where we start getting into some what if scenarios. Now, the original premise we were doing here was actually based upon my experiences with Lucky Dog. And when I was getting ready for the race, we had one endurance on one day and then one endurance on the next day. One was a 7 hour, one was an 8 hour. And what we started to look through, and I won't use that data today because I don't own that data, it's my colleagues, but I have taken data from another race to be able to illustrate. And we've been able to start looking at the fact it's like, okay, so if we finished 20 seconds behind the car in front, let's have a look at the consistency of each of the drivers. Let's figure out where each of the drivers is better than the other in certain areas. And let's start doing some scenario planning, which says that even if a driver found an additional 0.2 of a second in turns 7 at Portland International Raceway, aggregate that over a period of time with this driver versus this driver, how many additional seconds will be gained? And then we start getting to what if scenarios, which is everyone else stayed consistent. Would we have done better in the race, or would we need to find more? And start thinking about in different areas. In fact, I'm working on an analysis right now, which is extremely simple, but it's the argument to be made. I'm giving away what I'm going to talk about on YouTube, so no one will ever watch. But it's what's 1 second worth, right? And what is 1 second worth to a race car driver? What is half a second worth? And the idea being is that if you took a spec series and you took that spec series of people in the same race and the same conditions, and you were having a conversation with somebody who wasn't sure about the application of data, or they weren't sure where they can potentially find time, if you wanted to be able to convince that person to say, if everyone else stayed the same and you found a second of data, over, whether a period of a race or whether it was in qualifying, would you have qualified better? Where would you have qualified? If you've qualified better, what would you have done in the race if you'd found this much time? Some scenario planning, so some what if type situations. Now, some of it may seem pretty straightforward, but the more data you have, the more variables you're working with, the interesting sort of part of that conversation comes in. And I think that's particularly useful when we start thinking about data analysis. Interestingly, we did an analysis of a series in the Pacific Northwest. I won't say which one it was, but it's one that I used to race in. And there's lots of cars, and we found what is 1 second worth? Well, on average, it was worth about 4 positions over the period of a grid per driver. Now, if you're at the top and you're position number 1, it's not worth much more unless you want to be able to protect yourself from number 2, who may only need to find a thousandth of a second. And so it was interesting to be able to see what is 1 second worth. And so that gives you the what if scenarios. And then you start getting into comparisons. Yeah, we can do overlays of driver versus driver. That's always very interesting. And we can download the data and do conditional formatting and Excel formulas and all sorts of stuff. But again, let's see if AI can make that faster, easier, or better. And that's what we're looking at today, which is a lot of what I'm going to show you today. We could all probably sit and crank out if we sat with Excel and everything. But one of the things that I think we'll all appreciate is that when we're at the racetrack, we are time starved. It seems ridiculous, but we've got two problems with time. The first is that by the time we've had a good old natter with everyone else as to what happened in the race, and oh, I would have had you if I'd had another lap, or yeah, I haven't got as good an engine as you, or whatever list of millions of excuses that I obviously have, as per these webinars, gone through and created a database of excuses, you've started to forget all the stuff that actually happened on track. So one of the things that we want to be able to figure out is, how do I get off track? How do I analyze data? And then how do I download that information? So one of the things I saw someone wrote in a comment, which I absolutely loved as I went through the webinar chat, which I can't comment on everything, was someone was saying, oh, I've been writing notes and then using ChatGPT to go through that information. Absolutely right. In terms of the first thing that I ever learned, and I think it was from Ross Bentley or Don Kitch at the school in Seattle, was, make notes. Make notes of every corner. It's just funny, I'm dating myself now, but they would give us a track map, and you'd photocopy your track. Photocopy. How ancient is this? You'd photocopy your track map, or you'd print it out, and then you'd have the corners, and you'd write notes on each of the corners in terms of where it was. And I'm sure some people do that today. In fact, I was talking to people who are building apps that allow you to write notes when you're doing track walks, which I think is interesting, as I know that we've got some stuff in Race Studio 3 analysis to make notes. But all of this information is precious in terms of time. And then the other thing, even though we're on track in a Formula Ford race, for example, for 10 minutes, and there could be 4 hours towards the next race, it always comes around much faster than we have time to do data analysis. So speed is of the essence. The last thing we need to think about here is sort of different areas. So we're going to look at comparisons and consistency. This is where we get into stuff which is particularly interesting, which is, who's the best over 1 lap? All right, who's the best over 30 laps? And if you think about it from that point of view, yes, somebody may win 1 lap, but who's actually going to do the most amount of laps in the time that they're given? And so if you think about a lucky dog race, you get given 2 hours. If it's a 7 hour race, that's interesting, because now all of a sudden you can give a bit more time to someone and a bit less time to somebody else. And so if you've got someone who'll do a little bit more in terms of more laps or a quicker time in their 2 hours than somebody else, now your race strategy changes and you start thinking about it. So I'm going to think through some of that as we look at it today. Now, I'm actually going to use fresh data, so we could find my using the angry capitals later on, but we'll see how we just get on. So these are some of the things to think about. And so, Roger, if you wouldn't mind going to the next slide, the next thing I want to be able to talk about is choosing your AI tool. Now, there are so many tools to choose from. Anyone who is on social media through to, LinkedIn, Facebook, wherever need be, we're constantly seeing things saying, here are the top 10, here are the top 20 AI tools that you need to be able to know to go forward. And I've chosen 3 here, which I think all have easy access to all of us, because ChatGPT is by far the number one in terms of household name when it comes to prompts that you can put in a chat type AI environment. I think it's a fantastic tool. We use it a lot, especially if at work. Then you've got Google Gemini, again, wonderful tool. We'll do the same thing we're talking about today. And then you've got Copilot from Microsoft, which I've been using as this analysis. Now, you may be wondering, James, why have you used Copilot? Well, it's a simple scenario, which is if any of us do happen to have a PC, or we're using even the Mac versions of Office 365. In the UK, the price went up 50% this year because we're all paying for Copilot anyway. And so as ChatGPT costs £20 a month, I've already paid for Copilot. It's based upon the same models that are created as ChatGPT, so I'm not going to pay for 2. I'm just going to pay for 1. So that's the tool that I use. But figuring out which one works for you is important. However, I think it's really important to start thinking about the scenarios that you're looking through, because then you will start running into limitations as to which tool you're going to use. Now, because I pay for Copilot as part of my Office 365 subscription, the reason I bring that to everyone here, if you are using a race laptop, I suspect many of you do have a subscription to Office 365, whether it's to use PowerPoint or Word or whatever you're using. And so it's probably already included in what you've got. And I think many people may have that. If not, You may be limited in terms of the number of queries you can do. You may be limited in terms of the files you can upload. And these are all based upon the pay model for the AI tool that you're using. So just be aware of that as you're going in and starting to look at different sorts of areas. And you will see sort of limitations coming up where people are saying you have to have the pro version to be able to use this. Now, there are numbers of tools you can use. I actually tried another tool called Perplexity the other day, which also did a great job. But for everyone who's here as a consumer like me, these three are consumer friendly and we've all got access to them. Now, the other reason, and I'll talk about it later on as well, is that all three versions of these have mobile versions. Now, one of the things I do love is if you do analysis at home or if you're over a race weekend and you're in your motorhome or you're in your hotel or wherever you're staying, whatever analysis you do, you can carry with you the next day, which was particularly useful as we look through. So I'm going to use Copilot, but think about the ones you want to use. And I think that's an important thing. I'm pointing out the obvious. Somebody did ask me why I was using Copilot online today, and it was a very simple answer. So the next one, Roger, next slide is let's think about 3 steps for AI data analysis. Wow, this really is the most thrilling presentation so far. No pictures, just text. I think you're all probably sitting there going, oh my God, what is this? Well, don't worry. We're going to get into a demo in just a minute. But I wanted to talk about 3 steps because these are what I've personally been learning going forward. The first, just like anything, is that know your goals as to what you're looking for. One of the things that we often find with tools, now I work a lot with data and insights and consumer insights for my work, and we've got a lot of tools. And one of the messages we give to everyone is that you don't just turn on the tool and it tells you everything that's happening. You have to start asking it questions. You have to start probing it with queries, and then it will start giving information that you can work through. Now, the beauty of AI is that it facilitates this by being able to think through different sorts of ways of looking at things without you having to know Excel prompts or being able to do pivot tables or lookup tables or conditioning formatting or whatever we're looking at. And so that's been nice. But again, know what you're looking for. And I think this is the first thing that I see. For me, I've learned a lot. And so today we're going to use an endurance race and looking at driver improvements, consistency, comparison, lap times, segment analysis. The second is clean and get your data ready for the AI tool. Now, it will clean a lot of stuff. And one of the things that I will probably remind you all at the end of the day is that one of the use cases for AI is competitor analysis. And what I'm showing you today potentially will apply. So anyone who's got a transponder, most likely you're using MyLapse. And if you're using MyLapse, you've got access to SpeedHive. SpeedHive will allow you to download the results of any session that you've been part of. And so, for example, if you wanted to see qualifying information, if you wanted to be able to see full race data of all of your competitors as well, you can download that data. So it may not necessarily just be specific to having their data. If it's in the public domain in these environments, you can use it. If you're in the UK, and I know some series outside of the UK use it as well, TSL timing. Now, TSL timing, for example, gives you it in PDF, which you may be thinking, well, that's a nuisance. Well, one of the beauties of AI is it will happily turn a PDF into a table of data that you can work with in the blink of an eye. And so it's a very useful tool. And what's fascinating is that in some environments, the PDF download that you look at actually specifies which driver was in the car. And if you're at a track like a Formula One, so if it was Silverstone, for example, we race Formula Ford a lot at Silverstone. And you can see the sectors. So it will tell you sector analysis as well. So you can download a PDF and it will give you a lot of information you can analyze, which may just give you a lot of competitor information because then you can start looking at your sector analysis, their sector analysis, and say, well, they're doing much better in sector 2 than me, and start figuring out through your own data why that's happening. So think about it that way, but get your data ready for AI to analyze. I'm going to show you a little bit of that and how we get it out of Race Studio 3 analysis. And then the last thing, and this is probably the most important, because this is where you get into your rubbish in, rubbish out, is AI will look for key elements of the prompt to be able to do the best job. Now, Microsoft have actually helped us with Copilot by giving us a template as to how to talk to Copilot. And they've said your 4 key elements in your prompt need to include the goal. And the goal here is we know what we're looking for because we've set that up with our analysis goal. The context. This is really useful because you can start using, I'm at a racetrack. I'm racing at Portland International Raceway. I am racing in an open wheel. I'm racing in a closed wheel. Amazingly, the way that the language comes back is really particularly interesting. Then the source of the data, and the source of the data we'll look at is what we've downloaded, and then the expectation. Now, this is really important because this is where you start getting into this is what I expect from you as we start looking at an output. Because again, you don't know what you're looking for. And so this is where we get into aspects of what have we got in that data. So this is where it could go all brilliantly well, or it could go terribly wrong. And Roger's got the weirdest YouTube video to be able to put up, is that we're going to go to a live demonstration, I believe, which is my next one. So I'm going to start, Roger's going to stop sharing and I'm going to start. Before we get going, any questions on what we've just talked about there? No, everything else is looking good. And thank you to everyone. Did James say 70 other cars on track? Yes, yes, I did. It's not the most. I think the most I've ever done was a Thunder Hill race where there were 85, and I did do a can't remember what the series is called. They look like Volkswagen Beetles, but they're brand new Golfs
Fun
underneath.
Cup.
Fun Cup. Thank you, Roger. That was 135 cars at Spa. And so that was absolutely insane. Yeah, lots of interesting. So what I'm going to do is I'm going to share my desktop. Let's see if I can go straight to my desktop, which is here. I'm going to click on share. And right now you should be seeing Zoom. So your screen.
It's trying. It's I haven't seen it yet, but it's trying.
Your sharing is paused. How do I unpause the sharing? Resume.
I do not know that.
Okay.
It just says has started screen sharing. Double click to enter full screen mode. Try it again. See if she.
Okay, excellent. This is where even don't get to the AI because I don't know how to use Zoom.
Well, isn't that amazing? Share it again.
Let's
and
have
see
another
if.
Okay, so excellent. So
There
we're
you
here.
go. I'm seeing
There
it now.
we're here. You can see the fact that I was in the PowerPoint, following
you
on
go.
earlier, going, hope I don't miss anything as I'm going through it. So the first thing I'm going to go to is I'm going to go to Race Studio 3 Analysis. Now, hopefully you should see that. If you can, I'm not going to
Yes.
ask you again.
Yep.
All right,
see it.
lovely. So one of the things I'm going to do is I'm going to use data from quite some time ago. Now, this means that, you know, the data has passed. It's from July 22nd, 2017 at PIR. It is a racing series in a race car with 3 drivers. Now, this means that I'm not using anyone else's data, and obviously data, as we all know, is intellectual property, so I didn't want to be able to take that from somebody else. Now, what I'm going to do is I've just noticed that Zoom is just taking away my screen a little bit, so
There you go.
Thank you very much. So you should all be able to see. Now, what I'm going to do here is I'm going to do this. Now, I'm going to load these 3, and the first thing I'm going to do is I'm going to click on here, and I'm going to open with, look at this, I've got an AIM AI demo profile, as if I prepared, which I actually did. And the first thing it's going to do is it's come up with this profile that I created for Portland International Raceway. Now, there's a few things which are important on here. And the beauty of it is usually you can see my driving on these demos, and nobody knows if I'm driver 1, 2, or 3 until I look at which is the fastest. And yeah, clearly I'm driver 2, which I'm not. And so in this instance, you can see we've got all of the information about the fastest lap that we're looking for from each of the drivers, nothing unusual. But what I do want to be able to point out is that I've gone in here and we've got sector 1, S1, T1 to 3, T4 to 6, T7, S3. Now, you probably all figured out what that is. This is straight 1, this is turn 1 to 3, this is turn 4 to 6, this is turn 7, this is straight 3. Don't know where straight 2 went. That's an interesting one. It's probably lurking around somewhere. That doesn't matter, but that's just me not being very good at labeling things. Then this is turn 10 to 12, and then straight 4. Now, this is done on purpose because it's very important that we have this information if we want to do some of the AI analysis that we're looking at. And the simple reason being is that I'd use this anyway if I were doing analysis, but it's a key component of today's analysis. Now, I'm not going into how to do that. I'm sure many of you have seen many webinars as to how to be able to do that, so I'm not worried about being able to do that. But what it does allow us to do is it allows us to be able to create the split times report, which, as you can see here, is a lot of data. Now, if you were remembering earlier, we were talking about how many laps that were going on. Now, you can see that there's quite a few here in terms of each of the drivers. And if I scroll down, there's an absolute ton of information by each of the drivers. And if we think about the conditional formatting, you know, everything's green. Everything's great. There's not a huge amount except for a few areas where we're going to look at it. And it's so, can we use this? Is it useful? Well, yes, it's very useful, but we've got to start thinking about using it for something else. So what I'm going to do is I'm going to download it. Now, the number of questions I get asked on my YouTube channel and I get asked on email from people and on social media is, can I download my data to Excel? Honestly, I don't know, Roger, how many times you get asked, or Matt, or
A
anyone
lot,
on here,
a lot.
but it's a lot. And so the answer is yes. So we're going to click on this little red arrow here, and it gives you the opportunity of being able to export. And if you hover over, it says export split report to file. Now this is lovely because you can click here and you can export to either CSV or Microsoft Excel. We're just going to do to Excel. Now, I know Emiliano's on here. Emiliano, we're exporting to a very old version of Excel here, which means that my new version of Excel does not like the file format, so it won't let me save and analyze it. So just if that's possible to change, just while he's on the line, just to be able to ask. Anyway, for the people on YouTube, that means nothing. Sorry about that. So anyway, I'm going to click there, and it's going to put them into the file where I have all the data. Now you can see I've been messing around with this previously, and it puts it into the AIM RS3 exports that you have. Now, typically, I like to put this somewhere where I know where it is and I can find it. But I've already done that ahead of time to be able to make sure this presentation doesn't go on forever. And so what we've got here is, I'm just going to open this up. Now, this should open Excel. And here is all the data that it just downloaded. Most important things that are on here, sorry, excuse me, we've got the driver, we've got the sectors, we've got their outlet, we've got, the best. But interestingly right now, is this usable? Maybe, maybe not. So some of the stuff I generally tend to do is I will clean this file up to make it usable. So I'll start going in and I'll start deleting stuff. So here, for example, I will, get rid of this segment, and I will clean it up. Now, if I do that, it means that I get to a file. Where's my files? Because I'm using Zoom, I'm having an all. So it gets to a file that looks like this. So this is AIM demo file main. Now the reason it says main, just in case it doesn't work. I have practiced ahead of time to be able to show that AI is marvelous, but I haven't necessarily done a full rehearsal, which is when things go terribly wrong, and all of a sudden the question is AI right for me? So what I've done is I've gone in and I've just cleaned it up. I put the driver lap number of their stint, their lap time, and then each of the sectors. Deliberately left these in. This is using an AIM Solo. Interestingly, the person who owns this AIM Solo still has the same problems 8 years later. But at the same wish that one, it keeps hopping in and out of GPS. Now, interestingly, there are occasions where you get a little bit of a dash. Now, one of the things that's interesting here is we want to be able to say, well, does that make this data useful? Can we work with it? Don't you worry, we're going to start working with it. And so this is the data, this is the file. So now we've got the data ready to go, and we're going to start looking through our core principles, which is, what is the objective that we want to be able to solve? What is the goal we want to be able to do with AI? And then we're going to start thinking about, okay, based upon that, how do we start analyzing this data? And the things that we need to do. Now, what I'm going to do is I am going to shrink this. In fact, I'm going to turn that one off, delete that one. I'm going to bring this back up here. Excuse me while I organize my desktop. We'll move this one down here, do this, and leave the PowerPoint. Ooh, that's a sneaky one. So don't worry, it's just to save time. So I'm just going to save this and close it, because this is what we're going to use. Now, here we go in Copilot. Now, they've changed the interface lately. So now you get this lovely opportunity to be able to make a watercolor or 3D. This is only just recently they've allowed to do this. So the first thing we want to be able to think about in here is we want to be able to think about, first and foremost, the model we're going to use. Now, a quick response is when you want a quick answer to a question. And honestly, the amount of queries that are being done as you do research now by people using tools like Copilot, using tools like ChatGPT to plan things like, a vacation. Hey, I'm heading to the United Kingdom and I've got 5 days in London. I'm going to be staying here. Can you give me top 5 to 10 recommendations in terms of tourist attractions to be able to go and see? And this is the kind of food I like. And so these are the restaurants to find me as well. Simple stuff. That's a quick response that's being done. And the types of queries that are being done with that are monumental in terms of things that are happening. And I think it's absolutely lovely that that's what it's being used for. But we want to use it for a little bit of analysis. So down here, we've got the option of changing the model that's being used. Now, there is a think deeper version. This is where when you do the query, it really goes into all of the details of the analysis. Now, I love this, but it takes a long time. So for the purposes of today's demonstration, we're not going to use it. But for all of you, a very useful tool to be able to use, especially if you've got a paid version. Now, ChatGPT has the same thing. And then deep research. Now, this is my absolute favorite if I'm doing things for work and I want to be able to have something study, 1,000 websites at once to be able to read everything and then condense it down to a 5-page report. We're not doing that today as well, so we don't need it. But recently, they just launched GPT-5, and so we're going to use that because it says it's smart. And this is obviously clearly designed for me. And so it thinks quickly and deeply, which is perfect. So we're going to use that for anything we're doing. Now, first things first, we need to think about the ability for we need the ability for Copilot to be able to analyze the data. So what we're going to do is I've written a prompt which I'm not going to write out now because none of you wants to see me trying to do it. But let me just copy this and pop it into. Anyone notice here that I use a Mac a lot because I've forgotten all the buttons on Windows? So I'm going to type this in here. And the first thing it's going to do is I'm going to attach that file, upload. So this is the main one we're going to use. We're not going to use the backup yet. So attached to the file I'd like you to clean because I want it to clean the data. Remember the dashes that were in there and everything? It represents race car driver context from an endurance race. So now I'm starting to give it context. This is the context by which I'm giving it. And then I'm telling it what the columns mean because again, it doesn't know what the columns are until you explain. It can guess. And this, for anyone who's got a little bit of sort of interest, is called partial, or there's a partial prompting or a series of ways of zero shot prompting or semi-shot prompting. And basically, if you do zero shot, you're saying figure this stuff out without me giving you any context or information. And then there's partial, or there are different variations or words for it. And this is where you're starting to give it context. Now, to put it into context that we all would probably relate to, if I went to a prompt and I said, I like country and Western music. Can you give me some recommendations? It may create some recommendations. If you went and said, I like country and music, and my favorite artists are from the 60s, 70s, and 80s, so I like Johnny Cash and Dolly Parton and blah, 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 Kenny Rogers. It's like, right, oh, no problem. That's given me a bit more information that I can work with. And so when we're thinking about writing prompts, we have to be able to start giving it some information so that it can do a better job. So what I've done in here is that I've given it information to learn from. So I've said driver, that's driver 1, 2, or 3. Lap time in minutes and seconds. This is really useful because otherwise it might read it as something else. The driver lap number and their stint. The file then shows track broken into sectors. S sectors are straight, e.g. S1. And T sectors are turns, e.g. T4 to 6. Can you clean this data file for me by removing each of the driver's first and last laps, outlap and inlap? And this is where we get into endurance racing fun, right? And again, you have to figure out what your own personal prompt is in terms of this scenario. But what I've said is, can you get rid of the first and last lap? Because we know they're always a little bit hit or miss because it's in lap or out lap. So it's not useful for analysis. And then can you get rid of laps that are 10% greater than the driver's average and any within the sectors that they have? So then the driver's average is interesting because this means that if you're 10% and it's a 1 minute 30 lap, that's a 90-second lap. That means it's going to say anything more than 9 seconds over the average, I want you to get rid of, because there is a high probability at that point that if you're 9 seconds slower on a lap, something particularly significant has happened that you don't want to use for analysis because arguably it will mess up the lap. And we all know how AIM does the lap analysis. And so get rid of the laps that don't make any sense. And so then from there, and then the last thing is, and the laps I want you to get rid of where the sectors have a dash as this represents incomplete data. Once complete, we will do the analysis on only eligible laps. So let's see what it says. Now, chances are, here we go. It's just working through and it says, got it. We'll walk through, clean the process step by step. Ensure, remove each driver's first and last. Done. Tire warm up, pit exit, in laps. And see, I didn't write any of this. So remember we're starting talking about context. Now the system's going in and figuring out all the stuff it's learned and starting saying, okay, well, clearly it was tire warm up and pit exit and in laps and pit entry and cool down, which are not representative of race pace. Great. So the next thing it's going to do is going to go in any sectors where it contains dash is excluded. This catches laps where timing failed and the driver pitted mid-lap. Mm, maybe not, but it's a good effort. It's a good guess, but it doesn't matter because we just want that gone. After all, remove laps that are 10% slower than driver's average. Average lap time calculated after removing the first and last lap and incomplete laps. Threshold 1 to 1/10, as we talked about. This filters out major mistakes, traffic, or mechanical issues, which I totally agree. And if you had a mechanical issue and you then carried on and went normal average, then you've got a magic car. But at the same time, AI doesn't know that your car doesn't magically fix itself as you're going around. That being said, um, it wasn't IMSA, it was SRO, and someone just needed to reboot. And so they pulled off track, rebooted, and then went again, which I always think is interesting. And it happens a lot now at Le Mans and stuff like that. Not that we're ever going to be analyzing Le Mans data this way. And so what it's done is it's driver one initial and it started going into removing. And because it's giving you all the information, so I'm like, great, clean data sets, original laps after first lap removal, after incomplete removal, after 10% filter, eligible laps 48, driver two, 54, driver three. She's like, cool, this is really, really nice data, which is good. So now we can start analyzing this data. And this is where we get into some fun because you can start asking different questions. Now, the data set only contains representative race laps for each driver. If you like, we can do this. Now, what's going to happen, and this is what's lovely. Now, I haven't made these links, but I think they should potentially. But it will start giving you recommendations as to what it can do. Now, what's generally tending to happen here is Copilot is learning from me. This is one of the big difference between AI tools and search engines. Search engines, every query that you put in is usually well, the best way to describe it is cold. There's no real learning from the search engine beyond the fact that you may be male or female are interested in certain areas, in terms of certain aspects of what it shows you. There's not a huge amount that goes into previous chats and conversations. Whereas with AI, it's probably learning from things that I've done in the past. And we're going to get into using AI to be able to say, hey, look, I don't want to have to do this 100 times. Can you just remember what we've just done and do it again? Which we'll get into as well as we go through. So this is where we start getting into it. So I'm going to start and I'm going to go, okay, well, I want to validate this data first. And so I'm going to say using only eligible lap. It's funny, I'm one of those people who reads out as they type. Never stand behind me at the ATM machine, otherwise everyone will get my pen as I'm like. So anyway, where did I get to? Eligible lap, show me driver's fastest lap, and then their average lap for their stint. Can you also show me the delta between average and fastest? Oh, fattest, sorry, fastest. Right, see what it does. So this has gone in, it started looking through this particular details in terms of the fastest and, average and the information that is here. So that's particularly useful. So you can start seeing the delta between the two. And you're like, okay, well, this is quite useful. This stuff that I already knew, there's nothing necessarily majorly different here in terms of looking at it. Can we confirm? This is an interesting one. So again, big learning that I've had. AI doesn't know that lap times are based on the lowest number rather than the highest number. So just wanted to have a quick look. So this is where I start thinking, know some of the data that you've got. So can you confirm we're looking at lap times where the lowest lap time is the actual fastest, not the highest? The reason being, fastest. And this is giving it context. Will lap in a faster time, therefore smaller time in minutes, seconds than a slower drop. Can you confirm? Okay, so it's happy. Yeah, it's done the right thing, which is there. I'm like, great. All right, cool. So we started to get the information we're looking for. Fine with that. We can start getting into the details. Now I can rank direct the drivers versus average pace. Yeah, so let's ask one of their suggestions. Yeah, go ahead. Rank drivers by, I wish I could do this faster, by fastest lap and average pace. So we're using one of its suggestions now, and it's starting looking through. You're like, okay, great, useful, like that. But this is, something that we've already started to look at. Let's start looking at sector types. Let's do fastest and average.
There you go.
So here we go. So it's starting to look through fastest and average. So we're starting to look at delta between the fastest and the average. I'm like, this is really good. Now, sometimes it takes a while to be able to start loading the table. That's just an AI thing. That's more than anything else. Driver two is quickest in every sector, outright pace, and also has the smallest deltas. They're just not, they're just fast. Driver one is close to driver two in straights one, two, three, four, but loses in the technical turns. Now, this I see coming up a lot. And again, this is where I dig into the data. And all of you may be thinking, oh, hold on a second. How can a driver be fastest in S1, 2, 3, and 4, but loses it in the technical turns? Well, there's a few reasons for that. The first is, are they fast in, slow out, or slow in, fast out? And therefore, they're faster on the straights. That one thing we could look at. The second thing is, are the drivers doing a better job of being able to change gear? Now, this is a nuts thing to talk about, and I think it was somebody who taught me this a long time ago. But if you're a tenth slower per gear change and you've got 10 gear changes in a lap, you could arguably be 1 second slower than another driver just by changing gear. And that's an interesting thing. Now, what it does mean is you increase your risk of over revving the engine and blowing it to kingdom come. And so that's always a debate you have to work through. But one of the things that I've generally seen so many times is people who are saying, oh, that person's got a much better engine than me, and they're changing gear. Dun, 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 in terms of speed. There's no urgency in terms of what they're doing. And so we've got a lot to be able to think through. So let's start having a look at that. And we want to have a look a bit more. Can you compare each driver in each sector? There. And tell me which is fastest sector and which, and how far behind each of the other drivers are. There we go. So driver two goes fastest through all of these. Driver one's gap is, notable in certain areas, but interestingly against driver two, here's where the major difference is in terms. Now, I'm not going to get into the detailed analysis just yet, because again, we're just starting to look at data, but we've gone through 180 laps now to be able to start looking at some of this information as we're going through. And we're like, okay, well, if I start looking at this, these drivers are pretty consistent against each other, not terrible, but again, we're a tenth down, potentially over the average. If you're doing 60 laps, that time can start to add up, which is quite interesting. So, okay, before we don't even need to do that, I'm saying what I'm going to say to all of you. Can we start to look at stringing some sectors together? Can you show average time for each driver in the following? I want to be able to see, I know, turn 7. If you haven't been to Portland, just trust me. This is the turn 7 and straight 3. And turn 10, 11. Did I do 10 to 11 or 10 to 12? Can't remember. And turn 10 to 12 plus sector 4.
7 to 9 and your table right above there that you're showing.
Yeah, exactly. I've got them. Thank you. I've got here, which is interesting, seeing as those weren't the sectors I actually put in. So we've got to make sure that we're fine in terms of where we're going. So here we start looking at in terms of where we are. Pretty interesting. Driver 2, 37 point. Remember I said I was driver 2? Not that I was. But anyway, we can start looking at 7 and a straight 3. Now, this is a very interesting, almost hairpin turn at Portland that takes you down to the back straight. So now we're starting to look at what the delta is between the two. And you're like, okay, well, this is interesting. The differences here start to add up, which, we start looking at whether, if we look at turn 7, sector 3, 17.9. Again, I'm not going to do an analysis while I'm chatting to you because this is why I get lost in data all the time. But you can see that we start looking at different pieces of information of the sectors tied together. And so, I can now stack these combinations into a mini sector map. Let's see what it looks like. Again, this could be terrible. Let's find out what it looks like. So, okay. Stack these combinations to a mini. Yeah, so not sure I fully like this particular chart they're looking at. It's a little bit sort of Knight Rider-esque. I don't really understand what it's showing me, but at the same time, it's worth a try. And remember, I was talking about not trust the AI, but follow the prompts and do some of the AI analysis that is there. This is how we're starting to go through. Now, one of the things that we're starting to look at here is I'm starting to potentially get a little bit lost in the prompts, and I want to go back to where we're looking at. And so, okay, let's recap as to the analysis we've done so far. I want to see the drivers, fastest, average, then by sector, average, comparisons, and the combinations. And you put those to a quick. So we can see now all of a sudden we've got the information we were looking for, the sector analysis we're looking for, the combined sectors, which is great. Okay. Now this is where it gets interesting because it's not always perfect. Let's start to think about race prediction. How much time would be gained if each of the drivers, what was it, drivers, 1 and 3, made the improvements to the sector, let's just do overall, to their overall lap times, and how many seconds would that account for in a race that includes all these laps? Okay, so this is quite interesting because now what it's done is it said the eligible laps that were available, total time gained, if they found half a second, 7/10 of a second, the gain would be 26 seconds for driver 1, 37 seconds for driver 2. Now we know that, okay, so all of a sudden we've got, Michael Schumacher in as race number 2, and then we've got James in the other one. Can I ever match his potential capability? It's funny I picked Michael Schumacher. It's an odd choice, but shows how old I am. But you get the idea that all of a sudden we may have a delta that is here. And so starting to look at what this means in terms of performance, we can say, okay, well, we can find in this particularly interesting model, 63 seconds. And so we're looking at over a minute. Now, chances are we're not going to be able to find that. And so let's make this more realistic. How can we help each driver find 2/10 of a second? Oops. And what would that do to the overall lap time, overall race time across these? You get what I'm doing here is seeing if we can get something that's more realistic, because then we go back into what we all believe. And we all believe that this is more, this, by the way, this here, I didn't do this, didn't know this information, but if we went into race laps, we lost, if I remember rightly, the position ahead of us by 20 seconds. And so again, you'd be thinking, oh, that's rather convenient. He's put that on here in terms of what's going on. But effectively, what we're starting to look at is how do we start predicting what this means over the period of time? And notice, could I have done that with Excel? Yeah, could have done. Could I have done that in Ray Studio 3 analysis? Yeah, probably could have done. But at the same time, could I have done it as fast as AI just did in terms of being able to think through different scenarios? And so I think that this is where we get into it. So it says what this means in context will be almost 10 seconds back, gain just over 10 seconds, which in endurance racing terms could mean catching the next car ahead without relying on the traffic or a strategy lock, which is, again, I haven't put this information here. It's using information to be able to learn this. So I think this is particularly interesting there. And so it's gone in. So where to find the 2/10? And so both drivers are 0.29 off the driver two here. Even recovering 2/3 of this gap would hit the push 2/10 target. Driver one is +2 and 3 between 4 and 6. Again, if you know Portland, this is this twisty bit, which is particularly fascinating, which is here. Now it's got into braking. Now I haven't put any braking information in here, so this is where my brain goes into. All right, how do you know that? We don't know that. I haven't given you the sector times. I haven't given you the driver inputs. And so, this is potentially a bit of conjecture. But these two are particularly useful as we wanted to start digging in. And this is where I would go back into Race Studio 3. I'd start looking at the particular laps. I'd start looking at the driver inputs and I'd go back. Now, can I put this into AI? I'm sure you can do in terms of what's going on. So then in the purposes of time that we have, because I know I start bleating on a bit and I want to finish off in a few areas. It's okay. So I'm talking to each driver tomorrow morning before the race starts. Can you give me a summarized recap of what we've worked through today so I can sit down and propose these improvements to each of the drivers in question. Now, what it's done is it said, here is your information, pace by sector, combination sector analysis, because these are the two biggies that we wanted to be able to have a look at. Realistic improvement, where to find it. Driver one, you're close to driver two on peak, but the average is half a second slower. Biggest gains turn 4 and 6, turn 7 and 3. 0.2 gain will give us 10 seconds in race, enough to change position. Driver through, similar to one. Bigger advantage to gap in D2. Biggest gains turn 7 through to straight 3. And overall straight 3 straight speed. Interestingly, that's probably done by the time through that sector. 0.2 lap gain is 10 seconds, could close to the next car ahead. Benchmarking in all sectors, keep doing what you're doing, focus on consistency and traffic management. Oh, this is a new one. Haven't seen this. Let's see what it says. A one, please. The one page. Oh, not. Can't even read. And see what it says here. I love the fact that it puts a race car in here as well. That's my particular favorite as it adds in what we're actually doing. I love that. And it's going through and probably finishing this off. And you can see while it's working, it's going through here. And so it's going to work through this. Now, once it's done and it's worked through this, the last thing I'm going to actually ask it to do is I want it to do one last thing for me as we go through, which is I want you to be able to say, okay, next time I upload, this is important for everyone here. If you're trying to start doing this and you're like, what's happening? Next time I upload a file like this, can you give me a prompt to enter or a name for this analysis that I can just ask you to repeat the same thing? So this is it. So you just add this in. So you can either say run the endurance race eligible lat sector performance report on this file. That's all you need to do. And if I do, just out of interest to show that I've been working through different things, if I go into here, these are the three that I've made up so far. Remember I was saying what is 1 second worth in qualifying, universal aim data file and cleanup, universal race stint and sector prompt, which is what I have that is there. And so I have a series to be able to go through. Now, I'm going to stop sharing and hand back to you, Roger, so we can go through the final sort of bits and pieces. But I'd love to sort of think through questions and stuff afterwards, and then we can start thinking through, final questions, and then where we may want to take this going forward. So, this is an important component know something about the data so you can double check the initial analysis. This is super important. If you know that driver one has done a certain lap time because you can see it in Race Studio 3 analysis, the very first question that I asked will allow us immediately to be able to know if the AI is right or not. Because if it comes back and says the fastest lap we found is a 1 minute 42 and you know it's a 1 minute 35, you're like, can you double check that? Because in the actual file I uploaded, it said that the fastest race time was this. And it goes backwards and forwards and it says, okay, I'm going to go have a look and make sure I've done it. The second thing is ask AI to show workings. Now, one of the things that's fascinating with AI is we take it for gospel. We're like, okay, that's exactly what it should be. You're absolutely right. And if you're doing, imagine if you were doing all back at school or university doing a dissertation, like it's what your references are, just because I said so. It's sort of that's what it's doing, unless you tell it to do something different. So make sure it shows the workings so you can sure it's doing it right. Make sure you're using the right models so it can ensure that it's not doing a casual holiday search, but it's actually going into the data. If you want something from the A, just ask, a summary report for each driver or something like that. Don't be frightened of just asking for stuff and seeing what it comes back with. Now, this will take you down a rabbit hole. This happens to me an awful lot. And so this is a learning that I have, which is sometimes I now write that prompt, which is get me back to the beginning as to where I was thinking about in terms of all of these. Yeah, so Joshua, right, to ask you to figure out what the optimal lap time would be if you strung together all of the best sectors. If I could go back now, Joshua, that is probably the smartest question to be able to ask. I love that one, which is there. And I've probably gone through that in other ones, but not when I'm talking to lots of people. So yeah, brilliant question. I love that one. That would be a really nice one. Ask AI to remember your analysis. It saves a ton of time. Have the mobile versions available for trackside comparison. And so here's the thing. Data's everywhere. But it's also in Race Studio 3. So I see John asking, so how do I ask for improved by downloading steering, braking, lap time segment, and GPS lateral acceleration? I think these become, and so this was I was going to say, not that I want to invite myself back, Roger, because I don't want to be that person, but it's like invite me to your party. But I think there may be fun things to do in the future as we start playing with different things. So John's question is absolutely spot on. So my general belief is that trial and error would allow the system to be able to go through a lot of this data. And so if you think about a split times report, you could also do a channels report. And if you did a channels report, you could download your channels report per lap. And so I've already started thinking through this, which is what is is it causality or correlation between the fact that my lap times have gone down and my tire pressures have gone up 40%? Is there a way of being able to start looking through some of these particular variables we can look at, but also being able to see if there are other aspects? And so I've seen so many of these wonderful webinars where people have done trial and error. I particularly love one where I can't remember who was doing it. Maybe Ray Phillips was doing one using a Mazda MX-5 and changing suspension settings in iRacing and seeing what the data looked like afterwards. It was absolutely amazing because he had it to hand and he could just trudle off, do 5 laps with different suspension, come back again and analyze it. Well, great, but can the system find different settings, different variables? And so I genuinely think that there are so many different ways that I just wanted to start everyone off today with sort of some basic sort of thoughts, which is you can get the data into AI and start asking it questions and make those questions usable, which we did use. We found that we actually didn't finish as well in the second race, but we all found between half a second and three-quarter second. Now, interestingly, ambient temperature, it was nearly 90 something on Saturday and it was 75 on Sunday. So did that have a material impact on laps? Who knows? Maybe AI can find out in terms of things. But at the same time, I'm sure we could have gone and said, can you tell me what the weather conditions were for Portland on this particular time, minute, and day? And whether the information is available, we don't know, but you can ask. And so ultimately, I want to be able to sort of leave my part of this presentation by saying, I wanted to sort of, for want of a horrible phrase, whet everyone's appetite with what we could do, and then see where people take it from here. And so if improving download and steering, braking, lap time, all that, absolutely, because it's only a matter of time asking the questions. And then if you've got somebody like Roger or Matt or Emiliano or Ray or someone who comes on who's particularly gifted when it comes looking at the sort of suspension setups and everything, some of it may make sense, some of it may not. And I think we just got to start thinking through that. So I'll leave it there, but just wanted to say that AI is there to be able to work and help.
I think this has been fantastic. Some of the ways that you've showed us some things, especially those of us that haven't done much of this has been extremely helpful. And you brought in the data file. You talked. We didn't get into any deep detail about any of it, but we've wet the whistle.
Mhm.
We've planted the seed, right? And we absolutely would love to have you come back in a couple of months after you've done a little bit more. We've all played a little bit more. Let's kind of set a date at some point. But the interesting thing is that I thought was the best, the very eye-opening piece, as Emiliano said, was you're just asking the same questions. And I have found the little bit that I have used this, it has learned my way I like to speak. And
Yeah.
I have just asked the question in a normal way, and it comes back and replies back. It kind of knows what I'm asking, maybe even a little deeper than I do sometimes, right? Or it tries to guess, and often it's wrong. And you just reformat the question and you ask it in a normal way, and you end up getting these answers back that are very valuable. And I think there's a lot here. You showed us something that maybe a lot of us didn't understand fully, is how you get the cleaned up file into the AI program, and how you get it to start to look at it, and you define the context. That was something maybe I've been missing a little bit more, is allowing it to do the thinking. So you've helped us a ton. You've planted that seed. I think we all need to go back and play a little bit. And the other thing that I did see, you mentioned that the version of Excel that Ray Studio 3 outputs was maybe an older version, or definitely is an older version. And for those of you that were not here live, I seen Emiliano, our software engineer. He said, "Copy. We'll look into that and see what we can do." So I just wanted to kind of close that. Finish that loop a little bit for those of you that were maybe listening and saying, yes, I wish we would do that. And I think you planted the seed with Emiliano on that as well. So
Very
I,
cool.
I appreciate everything you've done here. I think it's such a topic that is so important, that we're using everywhere in the rest of our lives, and this is just another place where it is very, very valuable, and somewhere where I think we could all use this technology. So
Cool.
perfect.
Lovely.
Let's kind of start to wrap this one up a little bit, and I've been watching some of the comments. Everybody is just extremely happy and learned a lot today, and are wishing you will come back with after you played with it even deeper and more, and then come back and give us another couple, build on what we've done. This maybe we'll do this in two or three different short little pieces where we can just keep building on the stuff that we're talking about. We'll all learn a lot, I am certain. We'll have this video up on YouTube here very, very shortly, within the next couple of hours at the latest, and have this up there. Make sure if you're watching this live, that you go back and visit all the rest of the videos that we've done. They're all there waiting for you. Make sure you subscribe to that YouTube page as well, AIM Data on YouTube. The customer support. It's the end of the year. We got lots of big events coming up. I'll be at the NASA Nationals coming up here soon. Lots of our tech folks will be at lots of events all over the place. So make sure you give us a call at 800-718-9090 if you need some help, if you don't see us at the track. And look forward to seeing you guys all and making sure we're getting you the best information we can to help you get the most out of your hardware and your software. So our next webinar is going to be A Data Guy Goes Karting. Fellow that's been here in the chat has done many guest appearances here with us on webinars. Matt Romanowski from Trailbreak is going to be here, and he has purchased a couple of karts, and he's been out there with his family and playing around and doing some karting. So with a new Micron 6 and out there, we're going to talk with Matt about a data guy that goes karting, that's only been involved in the automotive side on road racing stuff, and now all of a sudden he's out there gathering data and learning a lot about karting analysis. So we're going to have a talk with Matt about that here on September 9th, 6 p.m. Pacific, 9 p.m. Eastern. Middle of your night, James, but I'm sure you'll be up and watching with us, right? So, no, but Matt's going to be here and joining us with that. I'm really, really looking forward to that. He's been learning a ton about some of the different ways you do data analysis in karting, so it'll be fun. the some contact information. James has a website and an email address there. We've put links in for his YouTube page where he has just tons of great content, technical information for AIM users. We'll have those links into the description box here below for here on YouTube as well. So the I appreciate it, James. You've been a friend for a long time. We've known each other for quite some time, and always valuable when you come and join us and share some of the information that you've thought through and presented so well here with us again. Thank you very much.
Thanks for having me. Lovely to be here again.
Absolutely. I hope everybody here enjoyed it. Give us a call, give us a holler if you need anything. There's the contact information. I appreciate everybody that has joined us, and I look forward to our next ones. Thanks again for everybody. Thanks again, James, and look forward to our next one. Talk to you all soon. Bye bye.